James Webb marks the beginning of a new era in astronomy. Webb expands and challenges our cosmology and our understanding of the planets and the origin of life. The beginning was hopefully a collapse. James Webb shocked scientists with a crisis. Will the crisis now get worse, or will the new discovery of the James Webb Telescope end the debate in physics? The debate about old theories and who is right or wrong is temporarily over. But what exactly does that mean? Have scientists really solved the mystery of James Webb's impossible discoveries, or are we just faced with weak explanations? James Webb was supposed to bring the solutions, but instead the $11 billion project in cosmology fell into a major crisis. All parts of the natural sciences dealing with space are currently experiencing the same kind of upheaval that we last saw in the Middle Ages, when the world switched to a heliocentric view. Now we may have to admit that the foundations of our modern physics are also flawed, and that we have come no closer to understanding what the cosmos really is. But how is that possible? Today's astrophysics, or in other words the science of physical quantities and relationships in the cosmos, is based on the fundamental laws of physics, which essentially come from antiquity, the Middle Ages, and especially from Sir Isaac Newton. The first observations of mechanics and dynamics were made in antiquity. Sizes and strengths were described for the first time. Later, Newton discovered gravity, which is so important to astrophysics. We have built our scientific observation of the universe on these foundations. We transferred the quantities and forces valid and observable on Earth into the universe, and this produced some consistent results. But then the space we see grew and expanded, and at some point the quantities we know are no longer adequate to describe what we see. This crisis began with the problem that different methods for measuring the age and expansion of the universe led to conflicting results. Local measurements based on astronomical objects in the universe gave different values than measurements of the early universe based on the cosmic microwave background radiation. We know this dissonance as the Hubble tension. The Hubble constant indicates the expansion rate of the universe, but in the summer of 2022, Webb discovered so many old and advanced galaxies in space that it raised doubts about the age of the universe. Our cosmos can hardly be 13.8 billion years old when, thanks to the Webb, we can see galaxies that were already well developed 200 to 300 million years after the Big Bang. According to our physical calculations, galaxies take billions of years to grow. For the galaxies found by Webb, this would even mean that they were formed before the Big Bang, challenging our old cosmology. That the universe began with the Big Bang 13.8 billion years ago, expanded since then, and went through a slow evolutionary process cannot be correct. We are at a crossroads. Either we are mistaken in thinking that our mundane physics can be applied to the entire universe, or we have so far understood only a small part of the physics that actually exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this maxim, all the physics of space should also be located on Earth. But perhaps we have overlooked the forces and dimensions on our planet that we now perceive in space. Webb breaks all records. It's wonderful. This telescope can detect very weak light signals. Webb's 18-tile mirrors effortlessly detect light that has traveled through space and time for more than 13 billion years. A special exposure method makes these weak spots visible for the first time. Thanks to a revolutionary new technique, for the first time in the summer of 2022, we saw light from the most distant galaxies that formed immediately after the Big Bang. These galaxies were both a sensation and a bitter disappointment. Instead of small galaxies, Webb shows fully developed galaxies that appear to be several billion years old. But at 13.5 or 13.6 billion years, that could never be the case. Scientists today sometimes say that the objects in the images are neither impossible nor real, but Webb can only show us the truth. Science must now admit that it has apparently been on the wrong track for over a century. Our standard cosmological model is about that old. What we see here is real. Webb works perfectly. It's just that a large part of our science still cannot accept the new truths. Some old traditionalists, unwilling to face the new truths, vehemently opposed the idea of a Big Bang ending or expansion. It also took years in the Middle Ages before the Church finally agreed to admit that the Earth was not the center of the universe, even though suddenly overwhelming evidence was being collected by astronomers across Europe. Not much seems to have changed, and although we consider ourselves much more modern, we have a similar scenario. Scientists who report new things may no longer end up in prison like Galileo Galilei, but disputes and hostility between scientists against new things still exist. Imagine that you have studied your life and firmly believed in something, and then suddenly you see images or another side of reality that tells a different story. Maybe your mind will rebel against it at first, and it will take time before you can accept the new truth. As with anything, there are some who adapt faster and others who take longer. Many open and young scientists are excited by Webb's discovery. This generation of open scientists includes Rohan Naidu, the discoverer of the glass, Z13 galaxy, and F. Stein, who discovered the galaxy. They look at Webb's pictures with an open mind and have studied them from the first moment of publication. Both astronomers have emphasized several times in interviews that we simply cannot know what is happening in astrophysics right now. We are still waiting for measurement results, research, and, of course, the latest images from Webb. Was it Hubble's fault? Let's look at the dilemma. One of the biggest controversies in modern cosmology concerns the Hubble constant. This is the rate at which the universe is expected to expand. Astronomer Edwin Hubble discovered in the 1920s that distant galaxies are moving away from us. From this, he concluded that the universe is expanding. The idea was later expanded, and the Belgian astronomer Lemaitre suggested that this expansion started from a single point, the Big Bang. Today, we already know through alternative methods that the motion of galaxies can be explained in other ways, and these approaches also give a unified picture as a whole. However, they were ignored for a long time because the old theories were considered more likely. But the more we see the universe, the more differences appear. It didn't just start with the Webb. Even 20 years ago, there were regions of space where the expansion behaved differently. It seemed that these areas were sometimes faster and sometimes slower, or maybe busier or emptier. This has led to speculation that there may have been multiple origins, or that our universe is even continuously fed by multiple sources, not all of which may have had a beginning at the same time, or at all. Once again, alternative ideas about the shape, nature, and age of the universe appeared, but scientists still stuck to the old theories about the Big Bang and expansion. This was probably a mistake. We have already briefly studied the Hubble tension.
In short, it shows clear differences in distance measurements in the universe depending on which fixed points we use as measurement constants. Scientists now hope that the Webb telescope will be able to resolve this tension as its mission progresses by accurately measuring the distances and redshifts of galaxies. The possible correction of errors in previous measurement methods not only represents an important turning point, but also holds the promise of initiating a transformative paradigm shift that will usher us into a new era of advanced physics that permeates the fabric of cosmic reality. This monumental achievement is a testament to the unwavering dedication and tireless determination of generations of scientists who have devoted their lives to unraveling the enigmatic mysteries of the universe, tirelessly pushing the boundaries of human knowledge in search of truth and understanding. In their relentless pursuit of knowledge, these intrepid explorers have not only expanded the horizons of our understanding of space, but also enriched our collective consciousness and inspired wonder and awe at the vastness and complexity of the cosmos around us. Standing on the shores of this new frontier, on the threshold of discovery, we must approach each new revelation with open minds and open hearts, embracing the possibilities of even the most unknown or shocking discoveries. Shape our understanding of the universe in profound and unexpected ways. In fact, the emergence of new theories and alternative explanations heralds the beginning of a new era in scientific research, where entrenched paradigms are challenged and bold new ideas challenge us into unknown realms of knowledge and inquiry. At this pivotal moment in history, we are on the brink of a profound scientific revolution, where the study of the universe's oldest points of light holds the tantalizing promise of revealing the deepest truths about the nature of existence. With the latest technologies, such as the James Webb Space Telescope, we are ready to embark on an unprecedented journey of discovery, diving deeper and deeper into the cosmic tapestry to unravel the mysteries of accretion disks, to explore the enigmatic worlds of the supermassive black, to pierce and peel back the layers of cosmic phenomena that make up the fabric of our universe.